Yeah, looks like it. So, hello everybody. Let's continue with our dead code elimination from last time. First, let's set up the editor. Okay. Oh, that's weird. The syntax highlighting is different. Shouldn't matter though. Okay, so since last time I did some searching in how other people do this, and I came across some improvements. So people tend to use data flow graphs to model this issue, and you can use those from Datalog as well. So the algorithm had to change a little bit. So instead of first searching for dead code, we start with searching for when a variable is live, and a variable is live if it is needed further on in the program. So it's a little bit the opposite way of thinking. And so a variable is live first of all if we have a successor between a certain line number and another line number. So in our simple language from last time, it's basically each following line that is a successor to the previous one. And if something is a successor and the variable is being used in a later line, then the variable is live on the current line. And that's the first case. Another case is variable is also live if it is again a successor, and then we do some kind of recursion. So we check if the variable is live on the second line number, but there should not be a define at that line number. If there is a define, then the value is overwritten and the value is not needed anymore. And that's all you need in Datalog to figure out if a variable is live at a certain line number. And with that, we can write down the dead code elimination pass. The dead code elimination basically says a certain line is dead code if you have a define at that line with a variable, but it is not live at that point, which I think is quite intuitive as well. One thing that I'm not sure about, but I would have to check it, is that you can have only one define on that line. If you define multiple variables on that line, then you would have to make this statement a little smarter. But in our language, we only have one define at a time, so then it all works out. And if you take a look at a scenario that we wrote last time, that's this one. So here we have an assignment and then a print statement and then two more assignments and a print statement. Only this line should be deleted. And I think that corresponds with this case. So here you see that you have only one assignment, then the print statement, then another assignment, and then another print statement. So it's smart enough to filter it out now. Then I added some more cases, but in the end it's all the same. One moment. Need to check if my chat is correctly working before I keep on talking into the void potentially. Let me also check it. Seems to work. Okay, so we have that. So now we can start refactoring, because I think the code has become a little unwieldy. And we can, if we refactor it, then the future improvements will become easier. So I think the algorithm is in a good state already, but all the rest, mainly this algorithm here, that code elimination function, yeah, it's quite a beast. So let's refactor it. First, this helper function, I think we can move it completely out of this function. Let me try that. Yeah, seems to compile. Let's see. Oh yeah, I forgot to mention this, but the successors, right now I computed it in a really silly way, so I just figure out, well, I can type this in GHC, I think that's easier. So what I did was I made a list from 0 to 10, for example, and then I said zip of x and drop 1 of x. Then you get a list of all the combinations of successors to one another, and yeah, then you can map over this list, and you can easily make all the successors. Oh, my bad, wrong shortcuts. But that, yeah, that's something I want to change in a minute. Let's see. Can we refactor this? So extract facts is used here, and it uses line number instruction. Okay, yeah, I think this can be moved out as well. No. Oh, right, it needs the program handle, but we can refactor that. Okay. Let's see. So then this. Okay. Yeah, I think that's fine. Yeah. So one thing, so that's it for the refactoring. It wasn't that bad after all. Well, I want to add some more stuff later, but yeah, I think the first thing we should try and add is an increment kind of thing. Because right now our language is really easy, and yeah, that's not really a real world use case. So increment of a variable, then line 35. So so what we want to do here is we have to update the variable. So it's a modify, and then oh, let me start up Google as well. Okay, and then so we want to update. Is it this one? Oh. If it is in the map, okay, that's not what we want, I think. I think what we want is adjust. Okay, yeah, I think we need that. So it just takes a function to modify and then the key and then the map, but yeah. Just so, and the key is the var name. Okay. Why is it not updating there? Okay, that's better. And now here we want to say that we want to increment, so it should be like this. And in this case, so yeah, now what we are doing is basically we are saying x becomes x plus 1. So we first need to read the variable and then we need to redefine it. So I think we just have to add both facts. So I need to this line and then this line. Is it really that simple? Time to find out. Okay, so what's a good use case? So first we need an assignment. Let's assign x to 1 or 1 to x, and then increment x, and then assign y to 2, and then print x. So only this should be deleted. Okay, and it seems like it worked. So yeah, I might have to make it a little bit more complicated, but it seems like it only deleted the assign y instruction. So, how can we make this more difficult? So if I print y, then it should delete nothing. Okay. If I add another increment, what happens then? It still understands it. Yeah, what else can you add? The language is really simple. So, what we can do is, let's do another assignment here of x and assign value 10. So this should be deleted and this. Okay, hang on a minute, that's strange. So now it's saying that this line needs to stay there. Oh, because it is being used here. Okay. Should we only put a use then? Let's see. Now it's not smart enough anymore because the define is gone, so yeah, now I'm just trying things. No, that's too much. That's strange. Why does it? So it sees that the increment has to be deleted, but not the assignment. But maybe, yeah, if you then run the algorithm again, then it will see that it has to delete it again. So maybe you have to run it until it hits like a fixed point. Okay. So let's add a comment and maybe fix this another time, or look into this another time. Or maybe look into it later, depends on how fast the other things go that I want to do. So let's first commit this. Add increment. Yeah, add handling of increments. Okay, so that's one thing. Another thing I want to do now is I want to refactor it so that yeah, let me see, where is that type defined? Here. So what I want to do next is I want to refactor the program and instruction types so that they become one. And then I want to add like a way of assigning the line numbers, or like have a way to map a unique number to each node in the AST. And then we can try adding if statements and see how that works. So I think what we need then is we need another, I think we need program constructor then. Or like a block, and that contains a list of instructions. But I want to rename this value then. I think it has to become like a statement kind of thing. Maybe shorten it to this to make it easier. Well, to avoid typing, I mean. And now everything breaks. So here we get a statement. Let me first rewrite all instructions to statements. That's a lot better. Yeah. Still not completely happy with the name statement. Maybe we should just call it AST or something. But that's easy once we did the rename. Yeah, now we can't reverse anymore. Yeah, I think we just need to go now. Okay, and now this becomes a list of statements. So what we have to do is we have to wrap all these things with a block. So map block. Okay. And here you get a statement. Oh, and here we can't do the simple numbering anymore. Yeah, let's. Can we fix this one? No. Okay, let's comment all this code out for a minute and start from a good state again. Okay, So what I first want to do is I want to create a way to easily generate the unique IDs, and then we can refactor the last part. So we need like a kind of supply data type. So I'm thinking we need like a state. So state monad, I mean. So yeah, I think that works. Well, it has to be state t. Then okay. Yeah, ideally you would have to wrap this in a new type, but let's do that later. First I want to get it working. So now I want a new value. So whoa, what is that? How should we call it? I don't want to call it int, so like an ID then. Oh, that's not what I want. Yeah, seems to be okay. Now we can say, we can write a function to give us back fresh ID. So like this. So current, yeah, and I know that there's a package for this, but it's so simple to write. It's easier to write than to find the package on package. And we modify it, and then we give back the current number. So what I'm saying is, give us the current number, the current ID. Hello, welcome. So what I'm saying is, for the supply monad, give us back the current value, modified, yeah, incremented basically, and then return the current value, or the previously current value. Okay. Oh, thanks for the follow. Yeah, I was in the middle of my thoughts here, so where was I? Yeah, so we have a way of creating unique IDs now, but we also need a way to run this. So nice. Well, yeah, don't worry. If I stream, it will be mostly Haskell and some Datalog. Maybe sometimes also a little bit of Elixir, but most of the time it's Haskell. So you're in the good place. Let's see. So what I want now is I want to go from this monad transformer to the underlying one. So, and we also need to give it like an initial value. So, action, I guess. And now I'm stuck again, which I can never remember which state function I need. Yeah, I think it's eval state t then. Oh, needs a monad constraint. Okay, then the action goes in here and the initial here. So yeah, we can write this more simply as flip. Okay. So we have a way now of getting unique values. But now I need to uncomment this code again. Or wait, hang on a minute. So let's start from the main. Yeah, and now it will complain that it can't find certain functions. So here we go from a statement to an IO statement, I think. Yeah. Yeah, printed no, cval also. Okay. Oh, and another thing we need to do is we need to be able to add line numbers to this language of ours. Yeah, how to do that easily. Well, I can simply add it in here, or we can use like a type variable. And then here it needs a type variable, and now it will complain it in a lot of places. Okay. Wait. That's a strange error. Oh, I think we need to add another argument here. Okay, this is becoming a little bit annoying. We have to add this unit everywhere. Let me comment out some code first. Nope. I first want to see which direction we want to go before I refactor everything. So here we have to evaluate a block of instructions. So here we can say like the fourth traverse go of the instructions. Oops. Okay, it's happy again. But what we want here is, yeah, let's annotate it is, and now we want to say run supply t, then the initial value is 0, and then here we need like an action. And it will give us back a monadic value. So here, let's call it annotate for now. Oh, and then pure annotate. Okay. This is a statement to probably going to refactor this massively later, but first I want to get it working. Yeah, so this is not unit, but it should be an ID. Okay, so this should be ID, and it's happy again. And here we need to pattern match on, for example, assign. Yes, so what I need here is give me a fresh ID. Oh, yeah, if I use ID, it will shadow the function in the prelude, so I need another, yeah, let's call it line number. Fresh, or we can call it statement ID. I have a feeling I will be refactoring a lot. Yeah, it's happy now. Increment is another one. And oh, no, it's the normal traverse, I think. Let's see. Still happy. Oh yeah, now it's saying that we are not using the algorithm, but we have a way of adding unique IDs to our AST. Maybe in a little bit clunky way, but it works. And now we should enable our algorithm again. It will probably break all over the place, but that's fine. So yeah, let's put this next to here. Okay, so here goes in a statement of unit, and here we get back statement ID. It should be fine. Okay, so one thing we need to do is we need to annotate it. So annotate it. Oh, this is the same line as here. So I guess we can delete this now. And here we can return annotated. Okay. So we have the nothing case that's working now. But in this case, yeah, what I did here previously was I assigned line numbers in a really silly way. And that doesn't have to happen anymore. So yeah, this line can be deleted then, the line numbers as well, but the successors thing will break. So we need a way of computing all the successors. Okay, that's going to be a challenge for later. So comment this line. Here we can say annotate. Oh. Yeah, that also changes quite a bit. So oh boy, there's so many errors. So simplify has to change. I think it becomes this. So simplify will take a set or a list of facts of all the dead code in our program, and then we can transform a certain statement into a simplified statement. But that will also break, I think. Yeah. Let's put some undefineds here so that we can focus on the extract facts function first. Let me see what's going on. Oh yeah, so now it's saying that this traverse is not possible because yeah, our statement data type is not traversable. But I think we can make it, but let's just do this first. So this becomes a statement of ID. Yes, so this becomes statement. This also, oh, we can use lambda case here. Oh, and here we need a line number. Okay, that's nice because here we have it. Because we did our, where did we do that? Okay, hello Soupy, welcome. Yeah, it's a little bit of a mess now, but I'm just trying to get it working, and then we can refactor it, and then I'll explain what I'm trying to do. It's probably a little bit messy right now. But yeah, I'm trying to get if statements into my language, and I need a better way of adding unique IDs to all the nodes in my AST. So I think normally you would do this maybe in the parser somewhere when you're going over the AST anyway, and then you create all the unique IDs along the way. Yeah, here it's a little bit different because we don't have a parser. Yeah, I should remove this line and separate it out from this function, because yeah, now that I think of it, it doesn't really belong here. So let's do that. So it should be like that, but it will give me more compiler errors. What's my code here? Yeah, just this. Okay. Becomes a little simpler, so I'm happy with that. Oh, yeah, this needs to become program now. Okay. I think we are where we used to be. Oh. And now it's saying, yeah, so this ID has to become an int32, or we can't push it to souffle. I think it only has support for int32 and words32. Okay, so it's happy again. Yeah, now we can choose. We can either do the simplify again or extract facts, but let's do extract facts first. We have the line number here. I don't think it's important. Then we have some instructions. Okay, so first of all, what we need to do is we need to go over the instructions. That's important, but is this the place to say where we have our successors? Not sure. Yeah, I'm not sure. Well, I think let's go with it for now. So, but I don't have an easy way to get the line number out. So let's make a function. Maybe I should call it getID. And maybe I should stop calling it line number in all the other places, but let's make this first. And increment. Okay, so what we can do is let line numbers map getID over the instructions, and then we can do the same trick as before. So we can say so now what we need to do is we need to create all the successors. So let's do a zip of all the line numbers and then drop the first one of the line numbers. Then you get a list. A list of IDs, and now we can say okay, so this is the same trick I did before. So we have the line numbers, and then we drop the first one, and then we get all the combinations, and then we add all of them, or we create successor facts for each one of those combinations, and then we add it to the result, then we add it to the souffle program so that it will be able to compute all the dead code later. So let's see. Okay, now this function needs to be fixed. Okay, so this line is fine, but what about this line? So what I think we need to do is we need to go over, we need to pattern match again and go all over the data structure again, and then check if the node is, if it is dead code, and if so, we need to remove it. Yeah. Let me see, how can we do this in an easy way? We can do this part. Nope. My thumb bindings are still broken. Okay. So, let's see. I think maybe we get a statement back, because if the statement itself is dead, then we remove the entire program. So here we say yeah, let's first start with this case. So if I element of that line numbers, then nothing else. Yeah, the same node. Well, just statements. And we have an issue on line 185 because, yeah. I have no idea where this is going to end up at. So let's maybe do this a little bit differently, so we don't have to do this all the time. Then we can do the same trick over and over again. So that makes me wonder if we can refactor it. Well, yeah, so if the optimized program is nothing, print optimized away, just what's going on here? Oh. Okay, it's starting to work, but I'm not sure we're completely finished yet. Because the recursion in here is not well. Get ID, yes. We can do that, so we don't have to pattern match here, but I think we still need to pattern match on the block, because the block itself has instructions, and that's, yeah, that can contain further that code. Because if we take a look at the scenarios that I enabled over here, it didn't delete anything. So what we're seeing now is, and it can be because of multiple reasons. So yeah, for this case, it didn't delete anything, and the same here. So yeah, we need to do some more work, but yeah, I think it's a good suggestion. Let's see. So what we can do is, I'm really running into naming problems because of the, let's call it node ID instead of ID. Just get ID for statements. And what we can do here is, if we have a block or we have something else, and here we can say if node ID, then we optimize this part away completely, and otherwise simplify. This is also not optimal, so that needs to be further refactored, I think. So let's see. we need to do here is block node ID and then simplify and map that over each of the instructions, and then do something like that. Oh boy. Okay, and in the other cases, what we can do is, yeah, I think the same as here. Oh, copied it wrong again. So if the node ID is an element of the dead line numbers, then nothing, and otherwise the statement. Is that better? No, it is not. Okay, where did it go wrong? Yeah, there's a lot of new code, so let's see. The supply thing, I think that's fine. So let's put that at the top. But we can see that the numbers being generated are fine. So we have 1, 2, 3, 4 in the second example. So that's fine. Yeah, the evaluator is also. Hey, wait! It is working. The second one has no dead code, but the first one, that assign y, is gone. Okay, so it's working again. So let's fix these scenarios. But maybe also let's make it easier to write this, because this is not fun. So yeah, we can use pattern synonyms here, or we can use a more low-tech solution. So let's make some helper functions. And then, oh, print is going to be annoying. Yeah, if we don't use the real print, we can hide it. I have a better idea. Let's do pattern synonyms. Because why not? But then I need to know the syntax. No, wait. Let's try this off. Another thing we can do is we can say just an underscore. That will work. Print is print, and we need increment. So that takes a var name. Statement. Okay. Oh, made a mistake here. And we need do we need block? No, not yet. So what we can do now is we can do this. I can't type today. Okay. Now it's complaining about increment because that's a scenario we haven't introduced yet. here we have our first increment, and here another one. So, okay, let's see. GU. Oh, okay, yes. Move the A to the end and use zip. What do you mean by that? The A in statement? Yeah, and then the Vim thing I have to remember for next time. But yeah. Wondering what you mean by move the A to the end. I'm confused. Before you found a nice solution. Was that the successors part? Like, yeah, I removed it here, but I added it back here again. Do you mean that? Also, let me check if it still works like we expect it to. So, here we have an assignment. And then this one should be deleted, and then that assignment is okay, that increment is also okay, and this one is deleted. Yeah, and this one is also okay. Seems to work. Let's look at this case. So I think that's this one. No. Yeah, yeah, it is. It's this one. No. Yeah, it's starting to become confusing with me because of all these extra numbers in between. But I think it works. Okay, so I think we need to refactor a little bit. So what we did was we added a way to create unique IDs using the supply monad, which is basically state monad, and then we have a fresh function which gives us back an ID. We have a way to run the monad, and now that we can create unique IDs, I had to annotate my statement with those IDs, and I did that in my annotate function here, which basically just pattern matches and goes all the way down. Yeah, it makes you wonder if you can do this using traversable, but that's something to check in a minute. And then what else did we do? Yeah, our dead code elimination, if it can be completely optimized away, then it might not return a program at all. So that's also maybe an interesting case to add. Yeah, let's add it to the end. That's easy to check. So if we have an assignment of x to 1, what happens? Okay. Yeah, so what's inside the block is optimized away completely, but not the block itself. Yeah, that's fine, I guess. Well, what we could do is the cat maybes part. We can make that smarter. Oh yeah, that would also work, but is zip width strong enough for what we want to do? Because it's not a simple list anymore. We have recursion now. And the recursion is, yeah, making it that I need to keep pattern matching on everything. But maybe there is that variant of zip with, but yeah, it's maybe something. That's an exercise for the viewer. Yeah, let's first continue here. So I had an idea about simplifying. So if we have a block and the block itself or the instructions inside, if they are empty, then we can remove the block completely. So yeah, I'm thinking we can use traversable now that statement has a type variable inside it. But first I want to fix the algorithm or make it a little smarter, and then I will take a look at simplifying it some more. Let's see. So here what I want to say is simplified instructions is, and then this entire part. Oh, and also cat maybes in front. And then it becomes really ugly, because now we can say if simplified instructions is that, then nothing else that. Oh, and now we need an equality, so let's add that. And now it says optimize away. But the code is absolutely hideous, so yeah. Let's see. I don't use guards that often in Haskell, but can you do this? And then nothing. And then, does this work? Let's try it out. I'm thinking no. Whoa. Well, let's do this for now. Let's see. So yeah, I'm also going to move this code to the top. So all the pieces that I'm happy with, I'm going to move to the top, so that we only end up with the code at the bottom that we still need to refactor. So the annotating, I think that's yeah, the easiest way to go. Yeah, well, maybe that can be done even simpler. Let's see. Yeah, let me first go over all the code, and then we will do it. We will review it step by step. So yeah, the evaluator is fine. The scenarios is also fine. We have some helper functions there to help us out. Then we have our algorithm. That's unchanged as well. Then we have the souffle setup code. That's also fine. And then here, what do we have here? Yeah, the nothing case. Yeah, that's also as simple as you can get. This part as well. Okay, so I think this function is fine too. And then here we have our extract facts, and I think this can be made simpler. And because here we have to do some manual pattern matching, and well, we have to do it anyway to add the specific facts. Yeah, I think extract facts is also the best we can get it. Get ID is fine. And then, yeah, this function is absolutely horrible. But I think we can make it simpler. So because I'm seeing, let's first refactor this part because that's also occurring here. So how should we call that? Let's start with simplify prime, and then a statement goes inside. Yeah, I need to move this in here, and then what I can do now is if node ID element of deadline numbers, is that in scope here? I'm not sure. Then nothing else results. Well, it's not really results. I need a better name for that. Okay, now it's complaining here, but yeah, if we use this new simplify function, we can write this down. So here we give it statements. And otherwise it's just statements. Bear with me. Yeah, it's still complaining that it doesn't know node ID here. So let's change that. Simplify. Oh. Okay. So the statement goes in. Wait, is that right? Yes, that's right, because that's the nothing part that will be handled, and otherwise we need to do this entire part. But we need to rewrite this. Oh, it's happy with this already. Nope, that's bad. I was trying out something, but it didn't work. This is quite the function. So either this simplify prime removes the statement completely, or we give it back like a changed statement. So this is like the original, and this is the changed or modified. That's maybe even a better name. And why was it complaining before about the just? That's strange. Oh. Because this can also return nothing. Okay, then we have to keep it this way. What I think we can do is we can do a case here. Let's try that out. Case of I like that a little bit better. Yeah, that's enough for one line now. Okay. So yeah, that's refactored a little bit. Still not completely happy with it, but for now it's fine, I guess. We have our main function, we have simplify, get ID. Oh yeah, about this. What's the signature of traverse again? No, I don't think we can do traverse because in our case we have a statement of A and then the function would get the A, and the A in our case is only the node ID, and that's not enough. We want to have the full statement, so we can't do traverse. That's too bad. Well, then I think this is the simplest we can get it. Okay. Yeah, let's commit this. Oh, maybe one final thing I want to do is change statements to AST. Okay, now we can add it. How should we call this? Use AST type instead of instruction. Okay, we have that. That's not that exciting yet, but the next thing that we can do is we can try adding ifs to our language. And an if has a certain line number or node ID. Then you have a piece of code. Yeah, well, we don't have booleans yet. But what I want is I want to have like a kind of jump instruction. Yeah, and what we can do, we do have integers, so we can do the JavaScript way, and if we have something that's 0, then we go to the false case, and otherwise we go to the true case. Oh, and this is the condition, the first AST node, then the true case, and then the false case. Okay, so let's add it. So the condition, true case, false case, and it needs to be annotated. So we need like, I also need to rename line number here with node ID. So I will do that in a second. So if line number, and then annotate C update t update f. Okay. So line number. Let's call this node ID. Wait. Like this. Okay. Yeah, our evaluator needs to understand if statements, so let's do that. So we have a condition, true case, false case. So what we need to do is we need to say yeah, so the condition result, we need to evaluate C. Let's see, what does that give us? Oh. Huh. Okay, that's a little strange. So our evaluator always gives us back IO. So what we would like is yeah, ideally you would pattern match on the condition and check if you have the value 0 inside or a variable that resolves to the value 0 and then either 0 or something else, and then you know which case to take. Okay, I think we need to modify the evaluator for that, but let's not do that now. I think the evaluator is not that useful at the moment anyway, so let's comment it. I can get back later to it. And then we need to remove it here. Okay. We don't need a bunch of imports now, so this. Okay, now here what we need to do is we have our if with our node ID and true case, condition, true case, false case. Here I also need to rename it to node ID, by the way. Node IDs. Okay, what do we want to do here? It's a little tricky. It's a little tricky because yeah, if the value here contains a variable, then yeah, we don't want to remove the condition, but then we also don't want to remove the if. So how do we do that? Well, what we definitely need to do is we need to traverse over the sub parts. And does that mean that we also have to go inside the condition branch? Not sure yet.
And also what we need to do is we need to get the node IDs of the true case and the false case. So let's is get ID t. And what we can say now is souffle add facts. Oh, successors. That's a good question. With just that code elimination, I don't think it's possible. I think you need to have like another kind of pass for that. But what I mainly want to try right now is if you have like a kind of jump in your program. Before we only had like from line 1 you go to 2 to 3 to 4 and so on. But now we have a jump. So yeah, maybe I should not call it if, but maybe I should call it a jump instead. But let's first see where we end up using this approach. So the successors here is let's see. And what we need, the current node ID of the if is followed by the either by the true ID or by the false ID. Maybe. I don't know those instructions. Let me look it up. Okay. So how does that work? So the instruction before it needs to have like the side effect of setting the flag, and then the jump will go to either the next instruction or to a way different instruction. Yeah, that's maybe something to keep in mind. Yeah, because yeah, right now I'm struggling with this here, the conditional. Yeah, it feels like the if is still too high level, and maybe we should be thinking on the level of jump. So what to do with conditional? So that itself is a node, so you would have to extract all the facts inside, and you can get the ID of the condition. Maybe the if does not need a node ID, but the node ID of the if is the ID of the condition. I think that's what's going wrong. Maybe, but let me try this. So the node ID is get ID of C. So now we have a link between the condition, which is on the line of the if, and then the true, which is on another line, and the false is on yet another line. And what we need to do now is, yeah, now we do have to add it here. I think it's like this. Oh, but yeah, we removed one argument, so we need to remove it here as well. And then it needs to be removed here. And then where is the if defined? And then here, whoa, what did I do here? That's bad. Okay. And here we need to say if we have an if, ctf, something like this, get id c. Oh boy, it's time to add a scenario. Let's copy this. So we don't have a way of executing the if now, but that's maybe something we can add later. But we can do that code elimination on it already, I think. So, oh, what I think we need to do. No, yeah, we can use plain if here. So if, and then what we need now is 3 parts. And what I need is a print x here, or a print, yeah, x here. And here we say, yeah, it doesn't really matter what we say here. Oh, that's it's actually kind of funny. We don't have a way to check our variable, what value it is. So, that's a little bit silly. Let's add that. But that means that we have to comment this for a minute. Okay, so let's see here. And that probably also solves our evaluator problem. So we need like a test or get value. Yeah, what you need is like a variable. Just a variable that we can look up. Add some more cases. For name. Oh, do. If we have a variable here, yeah, it's similar to an increment because then, yeah, basically this is a variable lookup, so we have to, we are using the variable. So, okay. Now we need to get the ID out of the variable. Yes, but do we have, are we mix and matching them? Well, you could have, yeah, another thing we could do is we could have assignments return the value that is being assigned. Then you get an assignment expression. An increment returns the variable value. But yeah, you're right. We're mix and matching expressions and statements. So that's maybe something else to fix in a minute. But first I'm focusing on the dead code elimination part right now. And then we will fix the expression statement thingy. Where was I? So I need to go to the scenarios. What we can do now is we can say variable x. We need to add a variable constructor. Is it happy with this? Oh, let's call it a variable. Yeah. Okay, and what we can do now is we can say that here we assign x equal to 2, and then, oh, that will be interesting. Oh, we have so many possibilities now. So let's see. If we do it like this, then it will look here and it will see that this will be needed, maybe, and then this might become that code, but that depends on what's being added here, I think. So if here we do print x also, what happens now? So I'm thinking, so this line is still there, this also, that also, and also. Okay. Can we make this delete some code? Let me think. Oh, we have a use here, so this one is definitely needed. So what if we name this y and then assign y to 2, for example? It still keeps the x because, yeah, x is needed here and here it's redefined. So if we redefine it here, would it be smart enough? Don't think so. No, still not. Let's see. Trying to think of a way how, when is a line dead code? Well, maybe first what we can try is we can let's make this a little simpler. So like this, and then here we say we have a block. And then inside we assign x to 2, and then assign x to 3, and it doesn't work. Why? I'm writing a dead code elimination pass. So yeah, and I'm using Souffle to do it. So it's a data log, and you can write down like facts and relations, and just with that you can write the complete analysis. And if you have that, then you can read the results back into Haskell, and then you can filter out all the dead code that we find. But what we were trying to do was adding if statements or expressions to the language. Oh, yeah, you're right. I never have a good place to put the camera. How do I fix that? Well, I think the time for compiler errors is mostly over, so let's move my camera to the top, like this. Hang on a minute. Middle of the screen, yes. So, yeah, I need to figure out a smarter setup, because yeah, if I put it in top of the corner now, like I just did, and if I have a type error, then it's also covering the output. So maybe I need to, have like a vertical space on the right where I have the camera and maybe the chat output or something. I need to think on that, because it keeps on being in the way, and it's not handy. Anyway, so I was explaining, so we write down the facts and relations in Datalog, and we have Haskell that can interact with it. And the algorithm in Datalog is really short, but it's really, exactly. You might think that it's the least critical, but if you have a compiler error, it ends up at the top. So if I write something like this, it's covering it again. So there's no good place. But I was saying, so the algorithm in Datalog is really short, and it captures a lot of cases, and then the Haskell code becomes simpler as well. But I think we went a little bit too fast with adding the if statement, or making our AST type recursive. So I need to figure out how to fix that. So one thing I'm noticing now is the block has a node ID of itself, but that also doesn't make a lot of sense. Like, we can do the same trick as with if and make the block node ID the same as the first instruction. Yeah. Would that help it? Let me see. Because right now it's not seeing that this is dead code, this line. Well, it should see that it's dead code because of the assignment here. Oh no. Okay, I just noticed multiple problems. So what we need to do, where was this? In the extract facts part, I think. So here I said that, oh, if we get the ID of the true case and the false case, then we can add the successors there. But there's also, like, after the if, you also need to get the IDs of these two branches and say that the successor of the if is the statement. Yeah, we need to say that we can go from the true case to the to the instruction past the if, and the same for the false case. Yeah, it's not that straightforward. So, how do we fix this? Because we said that what's going on right now is that it's marking the ID of the condition as the next one because of how block works. That's also not ideal. Well, we also need to do that, but we also need to add, like, we have to be able to jump from the true to the next instruction outside of the if. And we only have one instruction in here. How do you fix that? I think we need to write a helper function for the successors first. And then we can easily add them with add facts. And then we do leave the rest of the function for the rest of the algorithm. Yeah. Okay, let's just do that. So AST goes in. Well, no, let's make it pure. Give us back a list of that. Okay. Let's see. We need to pattern match. And the most important part is the block and the if. And all the other ones return empty array. Oh wow, that's impressive. I'm new to all of this, by the way. I'm by no means an expert. I'm just trying to figure out how this works if you use Haskell and Datalog. So bear with me. So here, what we want is, we need this line, I think. Node IDs. Yeah, I think that works. And then here you have, well, we can replicate this part. That's really good. Wow, only 2 weeks to write it. I still run into the same issue here. So what I think we need is get and ID. Then if we have a block and a list of instructions, and if we have an if, oh no. Oh, this is difficult. So what I need is, I need like a kind of helper function that gets me the last IDs, and it has to be multiple for each sub ASD. Yeah, but it has to return multiple if you have like an if, because yeah, you have 2 branches here, and what inside the if, there I can say that you can jump from the condition to the true case and from the condition to the false case. But I also need some place where I can say that you can jump from the true case to the next one and from the false case to the next one. Yeah, or the true case. Right? What I think we need to do is we need to go over I think here I think here we need to add some code. Well, what I want to write is, so let's write some pseudocode to make sure that we're on the same page. So let's say in a JavaScript or C-like language, if you have this, do stuff here, and then you have an else, do more stuff. And what I want to say is, this is line 1, for example, and this is line 2, line 3, line 4, and then let's make this line 5. What I want is, I want this list. So I want to say that from 1 you go to 2, or you go from 1 to 3, or you go from 2 to 5, and from 4 to 5. Completely messing it up because I'm thinking too much. Oh, and 3 is not really something. So 3, 4, and then this becomes, wait, hang on, so from 1 to 2, or from 1 to 3, and then from 2 to 4, and then from 3 to 4. Yes, I know, but Soufflé does this for us. So I'm thinking that I'm overlooking something here. So the magic of Soufflé is that you only have to write successor here. So if it is successor, then then on the data log side, it will automatically do something that works very similar to a control flow graph, but it looks like here we have to recreate it as well. Yeah. So if we can write this function, then Soufflé does the control flow graph part, and then you can, you get your dead code elimination for free. But I'm starting to notice that I only have like 9 more minutes, and then the stream ends for today. So I will probably have to continue it next time. But let's try and make it work in 9 minutes. What's the problem? So yeah, and what's going on here also is that we have like an instruction, and then we have our if, and then at the end we have the end of our block. So we need an easy way in Haskell to do all this. And what I think I did already was I have the link between this and this, and this and this. Oh, so we need 1 and 4 as well then? I'm not sure. Yeah, so what you are saying is 1 and 4 needs to be added, and maybe that these can be removed, but that breaks the algorithm, I think, because well what we need is we have a bunch of instructions here, and we need to be able to say that 2 is followed by 4 and 3 is followed by 4. Yeah, but I don't need get next ID. I think I need get last ID. So I don't think I need this case, but it's in there now. So that's also bad. It was going so well, and now we're stuck all of a sudden. Yeah, I think maybe I should end the stream here for today, and then think a little bit more on this, and then continue next week. We made quite some progress, but this if instruction, yeah, it needs to, yeah, it needs some more thinking. And I think once we have this, then we can figure out if the if is optimized the way correctly. Yeah, getting stuck is good. We did quite a lot of things actually. It's also a lot of code extra now. Yeah. Well, another way that we could have done it is maybe that we don't have. That's maybe another way to explore for next time, but successor, maybe we shouldn't write it directly in Haskell, but do it on the Datalog side. So so that instead you could have like a successor relation of line number and line number 2. And then here you would say, oh, we have an if, and then, yeah, do something with the if here, and then it figures it out that way. That might also be a possibility. But I need to think about what's the best way to proceed. Yeah, and also something for next time, because we didn't have time for it today, is I want to clean up the mixing of expressions and statements. So let me write that down here. So and I also want to fix the evaluator, and I think that will be easy after the first to do. Yeah, our scenarios are fine, but maybe, yeah, here we need more meaningful scenarios. And here, yeah. Yeah, we need to finish this function, so just a to do here. Then I know what to do for next time. Yeah, and the rest is fine, I think. Yeah. So plenty of to do, so we know what to do next time. So yeah, thank you all for coming, and see you next week maybe. Bye.